welcome to my channel. In this video, I'm gonna tell you about foundations and footings in civil engineering perspective. I already made PowerPoint presentation for this video and I also collect some pictures from Google to better understanding. Let's get into the video. First one, shallow foundations. We have four shallow foundations. First one is individual footings, combined footings, strip foundation and raft or mat foundation. And we have the definition for the shallow foundation. A shallow foundation is a type of building foundation that transfers building loads to the earth very near to the surface rather than to a subsurface layer or a range of depths as does as a deep foundation. Coming to the deep foundation, we have two types of deep foundations. First thing, pile foundation, and second one is drilled shafts or caissons. And we have a well foundation definition here. Well foundation is a type of deep foundation which is generally provided below the water level for bridges. Caissons or well have been in use for foundation of bridges and other structures. This is the example for the marine structures. And coming to the individual footing or isolated footing, here we see the picture of the individual footing. Here no footing is connected to each other. They laid individually in the earth. And coming to the combined footing, here you can see the combined footing. Two columns are connected to bottom one footing, so it's called as a combined footing. Coming to the strip footing, in this picture you can see the strips on both sides of the columns connected to the strips, so this is called as a strip footings. And coming to the raft or mat foundation, the bottom foundation is all about reinforced first, then you place the columns along the reinforcement. So this is called as a raft or mat foundation. These are used in the weak soil. And coming to the pile foundations, in the first picture we can see the lower density soils, medium density soils and high density soil. Whenever we have a low density of soil below earth, we want to give a pile foundation to the structure. The piles are going to deep into the soil to the high density soil, so they can place it inside the earth up to required depth. Whenever we have a piles and we have a pile cap on these piles, on pile cap, in the center of that pile cap we have a column. That piles transfer the loads coming from the column, and column transfers the load to the pile cap and pile cap transfer to the piles, and pile going to transfer the load to the soil. In third picture you can see the three types of soils: low density, medium density and high density. The piles are drilled along the high density soil. Drilled shafts are caissons. Here we have a definition for that. Drilled shafts, also referred to as drilled piers, caissons or bored piers, are deep foundation solution used to support structures with large axial and lateral loads by excavating cylindrical shafts into the ground and filling them with concrete. Here we have a pictures of the deep foundations. In first picture we can see one crane drilling the soil from top to the bottom. After that we place the reinforcement in that hole and we place the concrete. Coming to the footings, we have four types of footings. First one is flat footing, second stepped, and third one is sloped, and fourth one is eccentric footings. First one is flat or pad. You can see the plan. There is no deformations or angles in the footings. These all are plain. And coming to the stepped footing, we have a footing like that. You can see in the picture. The footing is constructed with the steps by steps, up to 3 or 4 steps. We have a stepped footing and pedestal in that column. We have a column to the sloped footing. We have a sloped footing here. For the sloped footing also, we have a pedestal to the column and connecting to the sloped footing. Coming to the eccentric footings, we have a difference between concentric footings and eccentric footings. As I said earlier, these footings are all concentric footings because that column is placed in the center of the footing. Coming to the eccentric footing, it's adjacent to the center. That means left side or right side of the footing we have a column.